lady. Nothing is set up yet. I'm late. Let me change that. Beep, boop. Close and start. And I need Discord. Do I? Yes. Let's join bitluni. Okay. Do they connect? My headphones. Here we go. Tests. Nice. Hello everyone. Oh, this. Where is the chat? Oh. I need the chat on screen. Let me check where is my it somehow died, so I will rehost it. Give me a sec. Here we go. There we are. Hello everyone. You peeps are not outside. It's so awesome, the weather. It's official. It's official. I tell you. It's here. Shorts and flip-flops. This is the season. Shorts and flip-flop seasons that last until September for me. Now I'm officially in flip-flop season mode. Who has a blood clog? Oh no. Okay. Hello Dutch. Hello Hannes. Hello Christian. Hello Johnny. Hello Kasper. Hello DIY. Hello Johannes. Hey Arabelle. Hello TMK. Hey Sonic. Hello all lurkers. So, a recap of last stream, which was quite upsetting because we did all the nice coding and did everything right, but stupid Eclipse was basically compiling DIY the blood clog. Oh no. Depression has kicked in. Oh, get some rest and sun. And good audiobooks. Highly recommend. Okay, so last stream we implemented collision detection or the shuffling with some random wait time. Where is it? Yeah, here, the randomizer, the shift XOR randomizer, and we have the checksum implemented, and then it didn't work. It didn't do anything. Oh, I don't know what was the issue. Yes, the issue was that supercluster base and supercluster blade and where is it? Let me open the other project as well. Megacluster. Who's what? Why? Under the bus? Why? What's that? What's going on? Oh no, this is supercluster. Where's the megacluster? Supercluster base blade. Wait. Recent solutions. Oh. No, not recent solutions. Recent projects. Where is this? Okay. Let me check that. Huh? I can't find the I can't find the blade. Oh, I can highly recommend the Blackmagic support. They took a day, but you know what? Okay, so I had this issue with it's my fault because I checked the box for beta program. So Blackmagic Resolve Studio will update to their beta version. And what happened is that my project that I'm editing right now about the Megacluster wouldn't load anymore. It was stuck at 100% and I wasn't able to work. Hey Casper on Twitch. And what was happening, I wasn't able to work. I would have like, I don't know, I couldn't access my edit, which has already thousands. Hey Lush Cider. Ah, promotion. No, thank you. There are different ways of contacting me about promotions. So I wasn't able to edit anymore, which is terrible because people are waiting for videos from me. And I tried to find a workaround, like exporting the project, importing it again. It uses a database, so it shouldn't be corrupted or anything. So it's Postgres database. And what I tried to do is then exporting the project and imported it into the cloud database, which is managed by Blackmagic, and I'm paying like $17 a month for that. And that would load after a few minutes. And after I loaded that one, the local version would also load. So really strange behavior. And I just sent them my project file and the logs and told them what was happening. And they within a day, they fixed the project. They said the project file or the project was corrupted in some way. They fixed the file and told me, okay, you need also to check for your driver, for your graphics card driver, which is a little bit old, and don't use the beta version and stuff like that. But what they did is basically they fixed the project so it's not annoying. And then I told them, okay, thanks very much, and please try to make it, virtually. Yeah, I disabled beta version now. And I just told them or responded that I would appreciate if they, or it would be cool if they would like find the cause of the broken project file and maybe do a gracefully handling of exceptions during the load procedure or something like that. So just a hint from a dev to another dev, because it seems like it's devs that are doing the support. Otherwise, I couldn't explain how they would debug my project file and then change it. Hey, Tech. So, customer support, Blackmagic, super cool. And okay, I pay the cloud thing, but I pay the cloud thing so I can work with a cutter and so on. But I didn't need to do the cloud thing, and they would give me the support anyways, even though I only paid once for the editing software. 10 minutes now, nothing shown. All right, so what was happening last time? We weren't able to debug or see the collisions. Hey Oleg. Hey Sniff. So what was happening last time is basically I used this. Oh, so I used copy to copy the project, and what happened is basically everything went right. The project was copied, renamed, and all the internals, the settings and so on, directories, file, everything was renamed correctly. But you know what happened? It would compile, whenever it compiled a different cached file from somewhere in temporary folders, because the output was supercluster blade base instead of supercluster blade. Even though there was in this, I checked the files, there is not a single instance in the whole project file, solution file, any file that says blade base, but it still output blade base elf. So I don't know what was going on with Eclipse in that case. It was probably, it had like an internal ID or something, or a temporary directory with a unique ID that it used with the supercluster blade base, and that was copied or cached. And when I restarted the IDE and reloaded the project into the solution, everything worked fine. I only noticed because after compilation I had like the IntelliSense showing errors, but I didn't see any arrows displayed like here. I wasn't hinted on the output. So what was the output? Console. I think no, it wasn't. Yeah, output didn't show any arrows, but there were problems listed here. So the compilation was done. Yeah, that's strange. It seems like it compiles the project where the files belongs to. Did CH guys? No, they didn't sponsor me, unfortunately. They would, I think. I think I got samples once or something. I ordered samples or something from them during the chip shortage, which was nice. But yeah, I didn't get any sponsorships there. Anyways, yeah, it compiles. Here we go. Now we have supercluster blade, not blade base, but where's the project? Wait, let me open. How do I find? No. How do I find? Wait. Can I export or something? No. Where's this project blade base? It's probably completely gone. Just can't find the headers. Yeah. It's a matter of settings. I'm really surprised how we were able to make the binary file and so on. Right click properties for what? Yeah. Oh yeah, here you go. Risc-V. Oh yeah. Okay. Let's go there. it opened the browser. Nice. It's full of features, but yeah. Where's Blade Base? It's gone. Huh? Was it deleted? Did we delete Blade Base? Oh no. Oh yeah, the other thing was we had, oh no, did we fix that already on stream, or this was this never tested because we didn't see it? We okay. So the issue we had is like using GPIOD. Was this done the time before? Anyways, that works. That was like, we can use GPIOD 0 and 1 now, because now that it compiled, everything was working, and I had like a signal on the blade at the GPIOD whatever. Where's my stuff? Yeah. So what did you do? Why does it show so many errors here? What is this? Field cannot be resolved. Yeah, blah blah blah, Mr. Freeman. All of a sudden it will be... No, it's not resolved. What? What? Again? Huh? Are you kidding me? Ah. I have no clue what's going on here. Still. Huh? Okay, I give up. Active project. Huh? What is going on? Okay, it does. Huh? Oh, come on. What is this crap? Okay, let me clean. Yeah, I don't know what the issue is. Why do we still see Blade Base here? Let me remove those. And that one as well. And that one. Ah. I don't know. Just restarting Eclipse made it break. Okay, you know what? New solution. Cancel. Maybe I should. Something is severely wrong with that one. Cannot open solution path. What are you talking about? You know what? Maybe because it's on my Google Drive. Let me check if I can put it in the Megacluster folder. So annoying. Code. Okay. It's so strange. Oop. I have no clue. Yeah, that doesn't matter. Solution is basically pointless at this point. I don't know why it even bothers. Restart soon. Okay, restart you. Solution. Let me move the code. Synology. Oh, by the way, Synology Drive. I did the new. I updated to the new client type. And Johnny, you recommended to use Quick Connect, or you said, or someone said that Quick Connect should find the shortest path. It didn't work. It uploaded always over my DSL and back to my server here. So I had to disable Quick Connect. It asked me, oh, do you want to use Quick Connect? No! And then it worked over LAN. It wasn't you? Okay. I would say the same. Okay, let me move the supercluster stuff. Oh, what happened to Sion yesterday? So he was doing his robot arm. So what was going on? Uploading. Okay. I don't know what happened there. Ah, it loads it. Okay. Let's build it. Now it compiles. Now it compiles. Oh. Oh, okay. Did he build his kit? What was the result? Okay, so that thing works. Now we need to get all my debugging stuff and reinstantiate Yeah. Oh! 4 of 6 words, that's cool. Yeah, usually he only streams like 2.5 hours. So he must be really pushing that one. Nice. No, that's not happening anymore. I'm now middle-aged, it's official. I just get already tired at 8 o'clock in the evening and wrong. Yeah? Oh! The HDMI cable isn't plugged in. I get that. Here we go. Ah. Oh! So, did it come? No. Yes, no, maybe. Another time. Okay, now we need to find out what's 7 to 8. on PCB way. I have no clue. You can always try. Maybe the LED wall version 3 has a link because it was sponsored by PCB way. Okay, here is one guy. Okay. What I wanted to see is what? Wait. Oh yeah. I'm using that one to sense clock basically. So this is clock. Oh yeah. Where is ground? Ground. The clock is shaped really strangely with that one. So stop. Look at that shape. So I'm not sure about that. Can someone explain what that is? What is that? I mean, it's a clock, but huh? Oh wait, there is no pull-up. Maybe with the pull-up it works better. But how do we upload and do debug at the same time? I have no clue. Wait. I think that thing still has the software on, so we could plug it in. Does the blade oh yeah, that's handshake. Okay. I mean, we can try to upload it. It uploaded it. Should we try to upload to the second one as well? So we might have 3 different. This is what's reset 0. Let's do reset 1 because then we have like. Oh wait, we have 2 processors talking there. Oh. Yeah, wait. We need to have not push pull. we need to, what is this? Open drain mode. Okay. Download. Boom. Boom. Okay, let's. Hey Rita, schönen Abend. Okay, peeps. Let's do magic smoke. I will record this. So that should be 3 processors at the whole thing here. There is no power. And how do we do power? Let's just power it up from power up from the USB. Magic smoke. Huh? Huh? Doesn't work. Oh, wait. Huh? It shuts off or what? Ah, strange. Okay, that one works. I don't know what's with that one here. Yeah, let's run the digital probe and see if we got anything on the bus. And we need the clock for that. But I don't see anything here. Oops. Huh? Oh wait, I have debug code on there. I don't see the base doing anything here. Uh-oh. Let me reset it. Broken. We might need to, since I can't find the other project, we might need to copy the project again. Sea waves. All right. No recording anymore. Yeah, I have the debug code still active here. So wait. Okay, that was that. So I don't need to actually do that part here. Wait, let me pin 3. Oh, B was we don't need that one anymore. Remap, and this is debug, but I can be your translator. A nice evening to Kasper. Clock 1. Okay, bus init. Let's compile it. Bloop. This week. What? You not trusting me? Why that? I'm a totally trustworthy person. Frey. Maybe we will have a couple after I'm done. CLK and IO. CLK and IO. Clock, and I think this is W. Yes, okay. IO, and this is reset. This is reset, and this is power again. Yellow is ground. Who did this? Okay, let's upload it. Okay. Compile. Oops. I don't see anything happening anymore. Uh-oh. Oh, now it took the bait. That's the Sigland with digital probe. So here it's more or less a logic analyzer, but it doesn't analyze a lot. It can use up to 16 channels, but that's about it. Okay, let's test again if we get any clock here from that device. And nothing. Uh-oh. Set clock. Wait, is it high though? Yeah, it's not pulled high. We need the clock here, the resistor, because it's not plugged in. Oh, okay. We need to pull up the clock here because we have how do I pull it up though? Yeah, I can do just putting the resistor in there. I have some sort of pull-up at the end. Wait, that's the wrong. Here. Oh, okay. What does it do? Why is it doing stuff? Huh? Okay, I need more grounds. It tries something. Is this the collision? Yeah, that doesn't... I mean, the data lines are basically not showing up. That's why it thinks it has collision every single time it tries to send. So this is basically... Oh yeah. I'll show you. Okay, what you see there is I check the clock, and what happens here, we don't have the pull-up resistors for the data lines. So what we see is it sees, oh, there is a collision on the first byte, and it tries again later. But this is what the randomized, it might be two processes, we don't know. So we need to plug it in here, but make the blade base also work again. So let me unplug this one. And we should use that one on the blade base. No, someone disconnected. It's too much stuff going on my desk here. Okay. .3D printer, switch tools. Can you make a video about that and upload this to your channel? You need like a new viral video. Okay. I think here. See. Clock, this, and then we need a reset. Mini double-sided cluster. Chip you posted. What chip did you post? Didn't see anything. Where? Can you post a link? Is this ground here? I don't need this ground. I need this ground and 3.3 volts here. Boom. Okay, let me check. Where exactly on the Discord? Megacluster channel? No. Oh, you mean the Terminator? Yeah. Yeah. Let's show it. Pop, pop, pop. Here. Oop. Okay. The 003 and 203. And I'm getting hungry again. I just ate some pasta an hour ago, but apparently it's not good enough. Okay, something's fishy here. Oh wait. Something's fishy here. Boop. Super brain? No, not really. Okay, let's use that as a ground. Yeah, nothing there. So do we clone the project? Let's try it. Try to replicate it. I don't know where my other project vanished. Was probably just destroyed. So, but fortunately we didn't do any extra. What's going on? Copy. Here we go. I should have cleaned it first. Damn. Location code, but it isn't here. Huh? Huh? What? What the f... No. Huh? What is... Let me check that. Properties. Megacluster code. Supercluster blade. Oh, supercluster blade base. But there is no such thing. Oh, what? That's in the wrong directory. Okay. Yeah, okay. That's alright. It's not under supercluster, it's under... that's alright. Okay, now we need to figure out again where the megacluster thingy base has... has all its stuff. Where's KiCad? KiCad. Okay. Let's fix it again. Let's fix it again, and I'm wondering now if I build this, if we get the same error. What? No. Okay. Blah blah blah, Mr. Freeman. We just need to fix that again. I don't know what happened to the other one. Okay, clock is PB2. GPIO B2 B2 data was PB8 B8 B oh. Uh-oh, no. Tip. Eight. So the R, okay, I think this is it. We just need to make it work. Oh no. Look at that. The other one has a problem still. Fool. Ah! Hey, Max. Okay. We need to start at 8, I think. 9, 10. Let's check again. BUS 12, I assume the other ones, because I try to keep them together. An 8-bit arrangement. Where's the B? Then here, bup. Okay, that's all right. B. B2. B2, yeah. Perry, blah blah blah, Mr. Freeman. Okay, let's just upload that. Ah! Do you see that? Where's Blade Base? Huh? Weird. I'm not sure if it compiled or not. It compiled that one. Okay. It looks selected. Clean project. Clean, let's check object files so we don't have mess ups here. Cluster map is still there. I don't know why map wasn't cleaned. Okay, come on. Blade base, build project. Okay, blade base. Come on, select this one already. You know what? I restart. Ah. Oh no, did I change the wrong file? I changed the wrong main file. It's all my fault. No! Buźka mrugająca okiem. Blade base. I just said that it depends on which file you have selected. Blade. Wait. Which one is that compiled? Blade. And that one? Blade base. Okay. And now... Yeah. Now we need to switch the code here. We just start at clock. Yeah, I know. I copied, moved the project to not have any stupid G drive related. Okay, blade and blade base, and now this is blade base. Ah, that's the only thing that I need to change. Okay. Yeah, for the download thing. Okay. One thing that I need to change. Alrighty. Look at that. That looks promising. That's the handshake, my friends. Data lines. This is the unique ID, and there is 0 for broadcast. We can do this handshake even like special. Nah, that's the state that we had last time already. Oh, and there is also our checksum at the end here. And we are missing... Oh, please. Don't tell me we didn't... Are we setting it high again? Yeah, it's set high again. Is it? Yeah, it's set high at the end. All right. Oh, invented. Yeah. Ah! I bumped into the... Okay. Oh, I like the word unvented. Unvented was also unvented in this one. Unvention is something that's moving on. Now, that was this one. Let's unplug it and plug in the blade again and fix that one because blade has problems. I found issues there. So, bop, 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 bop. Blade bay. Oh, that's only here. There are still like 8 more. 16 channel. 16 channel 1 giga samples. Siglant, and it plugs in with an HDMI cable. That's not an HDMI cable, but it's basically an HDMI cable. Look at that. No, it's not that expensive. I think the digital probe. Oh wait, you don't see anything. Okay, here we go. Yeah, boop. That's a Siglant one. I think it cost like $300 or something. And you attach it. There is more. And that's the HDMI cable. And it has a warning sticker, warning label, flag that's S-Bus. S-Bus, not an actual, HDMI. Yeah, it's quite strange. I think this was like even a prototype device at that time. It's one of my first sponsorships on my channel. Is a review for this scope, and the payment was the scope and the probe here. I didn't get any cash, and I made it a 2-part. I think. Did I make the follow-up? I thought I will review the digital probe, but I might not have reviewed it. Hey Web, Max Web. On the PC, no, you can't plug it into a graphics card, I believe. It has no USB or anything. It's just a serial bus connection here. I would really, if I was like, I have this because I wanted something with hello Anna. Hello. Oh, nice. So we wanted to upload fix the other one. Getting distracted here. Boop, boop. Let's go. We are a new engineering student. Let's go. Yeah, we need to fix blade because I found an issue there. This is all right. $700? What? Okay. I think you should just buy a small logic analyzer. Okay, it's 1 giga sample per second, but really it's I don't know. Maybe because of the clock speed, but most of the time you don't need that clock speed. Yeah, it doesn't do much analysis anyway, so I can let it decode. Okay, yeah, that's true, with 16 channels. But on the other hand, you have only digital channels. That's not like analog channels. It's probably like triggered by 1.6 volts or something. I don't know what's the lowest voltage. The Siglant is 1 giga samples per second. On dual channel and quad channel is 500 megasamples, but that is samples, not like actual resolution. I think you might need like the actual resolution would be maybe 200 megahertz or something. What is Salea? About what? What, Max? What kind of suggestions do you want? Advice for what? I can give you a random advice. One advice would be see your parents as human beings, and they make mistakes, and it's easier to live with the status quo if you accept that your parents are humans and do mistakes as well. Oh, about embedded systems. Okay, different advice then. Embedded systems, I would say get a microcontroller and start tinkering around. Make a blink program with an old school Arduino Nano or ESP32. That's cool. If you're into coding, if you want to like do. Oh wow, what? That's 32 channel. What? What is that? Oh wow. Hey Hex, let me see you. You're jumping to STM32? Yeah, I mean that's a good pick always, but Raspberry Pi Pico is a good one. I mean it's FPGA. Yeah, try the Gowin. The Gowin of FPGAs, the Tang Nano 9K and 20K are quite cheap. Or some ice board. Oh, peeps. Take a look. Oh, broken link for me at least. Okay, so the problem is here we're enabling a nice, that's a good one. Then you're covered for ages. You can do anything. Oh yeah, nice. Cool. I think we recently had a live stream. Maybe you watched that one where we tried to do this DOS emulator. We uploaded one that does basically everything. I think it was on the Tang Nano 9K, or was it the 20K? And now, still broken. Look at this. Przepraszamy, nie znaleziono porządnej strony. No, Pożądanej strony, sorry. Sorry. Rolling the R. Social media, yeah, at bitluni, everything at bitluni on TikTok, but there it's mixed. There is Twitter, Mastodon, or chaos.social at bitluni, and what other socials? Instagram is at bitluni, everything at bitluni, and YouTube basically you found it already, bitluni's lab, unfortunately, because my name is locked there. Web usually, yeah. Oh yeah, Twitch is also running in parallel here, so you can watch on YouTube or Twitch. Every Wednesday, 8 o'clock in the evening. eBay. You're not giving up here. Ah. No, that works. Look at that. That's cool. $440. I would totally get rather that, something that you can attach to a PC, than to an oscilloscope, because like oscilloscope is always proprietary, and you have a universal serial bus here, which is probably cool. And then you can have probably some kind of third-party software as well. Blah. Okay, so pin 0 on D. So did we enable D enable and A enable? So that was a problem. Cluster blades. That's downloaded. Okay. Okay, I uploaded it to the blade. I should really I should make this a connector, because every time, you know what, we make this a connector, because I need to plug it into the let's make it a connector. Oops. I need to plug it in always, so we will probably, it's not the last time that we trying to plug it in and out. Okay, new connector. New connector established. Focus. Ah! Hey there, Markus. What? Yeah. Classic era. Yeah, not that bad. I hurt my hand during gardening today. So some skin missing here, and many scratches here. Classic. And I even used gloves all of the time, almost all of the time. You're out of limits for electronic stuff for now? Okay, is it still? It's still not solid. Oh, sorry. Yeah, this is the new connector. This is the bitluni JTAG with this pull-up resistor here. Let's do it. Let's see if we can. Okay, first of all, we connect the power. Okay, let's record this for you. Okay, this is the base. Now we plug that in and hope we don't get smoke. Did you see that? What? Wait. Wait. No way. Let's take a look at the IDs. Can we? Is this the first time we are recording collisions? Look at that. Okay, wait a second. Okay, let's take a look. What? No way. Okay. Yeah, they're fighting for bus, but if we can discover all the. So we have C5, C2. Maybe we should check what kind of MCUs we have there. Can we discover that? Okay, we have C5. I will take notes. Now we can wrap up the stream. Oh, I will probably replace the resistors. Look at that. This is like the slope is way too shallow. We need faster pull-ups, like 1K or something. Yeah, I will write down numbers if I can find a pen. I don't own a pen. Anyone owns a pen here? Let me get a pen and maybe a cake. More. Darf ich eins? Sind das mit Heidelbeeren? Kirschen? Kleine Kirschen? Donation for pen. You're great. More I found a pencil here. And I got this nice cake here. Tony just made them. That's cherries and some. Oh, very buttery. I can. Okay, that's 5. Okay, C5, C2, 5A, BC, BC, CD, AB, EC, and the last one is 2A. Oh, come on, too many. 2A. Okay. Next one. Oh no. Oh, that's not blueberries. That's cherries, small cherries. We don't need to checksum. Do we? Checksum is 41. Then we have silence. Then we have a CD, AB, F7, OC, 59, BC, 1D, 7, 5. Okay, that's a new one. We have like 3 different CPUs. So Caspar transitioned to flirting. C5. Oh wait, we know that one. We know that one already. This one is known. This one is known. This is the first one. Okay, so we have crude pen, CDAB, F7, that's the same. C5, C2. Okay, but there is no third CPU. CDAB, F7. They're just alternating right now. C5, C5, CD, C5. They're not even colliding. They don't even think about colliding anymore. Alright, but where's the third one? Third one not responding. Shoot. Okay. We need to plug our debugging tool and try to program all of them. So debugging tool. Okay. Ah, you want to donate a sub. Cool, thank you. I hope I don't short it here. Okay, connector might have worked. I don't know. I just plug in and see if it shorts. Oh no, I have the reset mounted in place. Now there is no way of switching it. We can do No, it might have not been programmed, so we need to try to get, where's the Mon River? Yeah. The third one is
Excuse? And the other ones, blah, 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 blah. Like me. I try, I unfortunately, sometimes I talk over people. External tool. Okay, here we go. Let's check if this is on my notes here. Is it? Nobody knows. Pook, cook, cook. Looky, looky. Which one is it? CDAB, yeah. F7OC59. BC. That's a good one. Stop talking when I'm typing. Okay, so we got that one. How about we try to get the other one with the other reset? But, shit. But now I glued everything in place. Foo. That was stupid to not... Okay, I need to release the reset and make it more flexible or something. Oh no. I just bend it in place. Yeah. Okay, we might need to might need to release the Kraken now, to release the connector and redo it because it's not flexible enough. Foo. Now everything is glued. With a lighter. Who's there? Hey, the 80. You missed the show. We had first collisions. Now we need the... Alright. I need just two different thingies to... Okay. Can we... Oh no, the second one isn't responding. Shit. Oh no. We don't get the second MCU. We don't get the second MCU here. Shit. I can try another blade, but... let's try another blade. What? No, yeah, this is not...
Not responding to the reset. Okay, let me get that one. Okay, so we have CD AB 96 OC 59 BC BA 74 download that. Oop. Now I will try the different resets if we even need this at all. Nope. It always responds with the first MCU. Shoot. Oh no. Hey Tops Bobs. So what do? We need to check what's happening here, because somehow it's not getting us anywhere. I can't program the second one. Let me check if we messed up there. If I need to... I mean, we can just plug in the two blades and then we will have a collision stuff going on with two blades. Okay, so we have SW R1, R2, R1 reset, SDIO, SDIO. No, it's correct. Everything is correct. So they are sharing. Try to simulate. Now the problem is that only one response here. Shit, how do we do this? We have two on the same... We have two on the same line and reset doesn't... High speed, disable stop mode reset. What is stop mode reset? Does anyone know? I did it for quite a lot, yeah. How do we fix that? How do I program the second MCU without like disabling the other one? What is this stop mode help manual? Yeah. generic. I mean, we can try connecting both blades, but then only like half of it is working. It's not, it's like the tool is like an external tool. It's not Moon River. Okay, so I have two blades connected. Let's see if we can get multiple CPUs fighting. No worries. Okay. Okay, that's 3 MCUs broadcasting. Let's take a closer look. We have CD AB8 too? Huh? I have 9.6, not 8.2. Is there a new player? 5.9 BC. I mean, it's the same batch, but also BC, or it's a collision. A8, A874. So two of the bytes are different. Then we have C5, C2, that's the main one. It has like 41 checksum or something. Yeah, hex 41. Then we have CD AB82 again. C5. Yeah, maybe. CDAB 82 again. OC. That doesn't look good. Yeah, but then why is it? Let me get different data here. Okay, 41 checksum. Then we have 10 checksum of 10, 41, 10, 41, 10, 41. Something's off. 96, 82 to 96 is 14. So it doesn't make sense pulling down. Yeah, that's either the wait time is too low, but we have like a bigger wait time, or it's not used at all. But we saw a wait time before. Checksum 10, 41, 10. Okay, let me unplug one
Yes, it's implemented. And we saw it already. D1, okay. D1, we can make a longer wait time. D1, 41, D1. D1, okay, now another one dominates. And is it one that we got before? 7-4, yes. That's the new blade. Okay, I unplug that one. And plug in that one. Maybe they were colliding all the time, but that would be really strange. Okay, let's run again. Might be, yeah. Okay, do we have... No! Look at that, that's 10. One is dominating there. 7 OC 5-9 BC 1D 7-5. Oh no, that's actually oh wait, the checksum is still 1-0. Oh, is this a coincidence? Because that we got 2 times the like a valid. There is no data sheet right now. It's all invented. Let me capture it. Stop. And see what we got. 7-5. BS protocol. CDAB F7 OC 5-9 BC 1D 7-5. That's 10H. Then we have C5 CDAB Oh wow. Okay, shit. One dominates again. C5 again. The wait times are too short. Or whatever. Yeah, wait times are too short. We have no wait time on success. Something's off. AB 7 1D 7. Yeah, we see never the second one. The second MCU never comes up. Oh no. Oh shit, I'm recording for 7 minutes. My poor hard drive. Alright. So, what do we do? Do we change the pull-up resistors or do we fix the protocol and check if the wait time is used at all? Okay, wait time. Send. Which song? There is no wait time set here. So wait time is only set on collision, which is not that great. So usually we would need to add wait time. So idle if in case of idle, high clock count, data ready, data out delay. Okay, so we do the following. On a successful submission, we need to fix it as well. So there is send data out delay, broken a collision, no collision, data matches clock count. Clock count else equals high clock count I will put it here again, so more bytes left. Yeah, state idle, and we will need to, and since this is false idle, this needs to be last. This needs to be lie. Idle state, it will always kick. What? Yeah, but I need to initialize it at some point. I think I will do it here. Where is it? There. Data out delay. Oh. So we need to wait every single time, and then, oops, I need to have the same bus here and there. So we need to reprogram them both. So bloop, which one is this? Wait, what did I do? Uh-oh. Oh, blade base, that's all right. Okay, yeah, so that one will wait. Now we need to make the blades wait as well. So after a successful, currently the bus is always blocked when the transmission was successful without a collision. And the one, basically what we were mocking was actually happening there. That one poor guy was always waiting for the bus to be free, but the two other guys were talking all the time without an interruption. That's the wrong one. Huh? Blade base? Blade base. Supercaster blade. Now it works, okay. Blade. I will just spam it so it writes, yeah, okay. Hi, half Greek geek. That's a cool name. Okay. Let me try to plug that here as well. We didn't even check if it works. Okay. Let's see if it works with just the base. Our code, we are just confident. Oh no. What? Uh-oh. Yeah. Uh-oh. It's not sending anything. Oh no. Blade, oh it says blade here. Blade base. Okay. Data out index. That was the first. Yes. That's a Rust, I don't know. If there is a way to use that with those chips. Data out delay. Just that broke it or what? No, can't be. Let me see what's going on here. Blade base. Now it works. Ah! Maybe I uploaded the wrong one, but here you go. Look at the delay. Whoop. The screen is like super delayed, but when I pause, it's alright. Okay, so we have delays here. Now I hope that we uploaded the right one here. Let's plug in a blade. Let's plug in a blade. Yeah, you see on the bottom. You see on the bottom here. Now I plug in a blade. Okay, now the two are talking. Let's plug in a... Are they? Yes, they are. Let's plug in a second blade. Is this more denser? Yeah. Okay, now let's check. Let's check if we get different MCUs talking here. We have CDAB 9.4. 9.4? We don't have a 9.4. Is this a new one? Okay, let me check. 9.4. OC 5.9 BC BA 7.4. That looks like quite similar except for one bit. But you see that here might be a collision as well. I have no clue. Let's move to the next one. CDAB 82. Oh, we know that one already. 82A8. Okay, we know that one. We saw that one before. Then we have CDAB 82 A8 0C59 BC. Okay, that was the same as before. Except I see a glitch here. Wondering if there is maybe the readback is not working properly. C5. Oh yeah, that's our host CPU. C2 5A BC CDAB. Yeah, that one is correct. Oh, you can't see that. It's too small here. You can see the hex decoding. Okay, CDAB F6. That's a new one. Never saw that one before. 59 BC 1D 1C 1C 575. That's again it's wrong. CDAB 94 OC blah 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 BA. We have like 5 different CPUs there. That's not possible. No, not 5, 6. I saw 6 different. No, that's not happening. All right. Maybe also we got wrong decoding here, but because the digital probe, sometimes you have like small glitches here. But let's see. 82, that's that one. Then we have CDAB 97 F6. That's that one. Hey Cavoli. Now, long time, nothing. Huh? So, why is this so much wait time? It's so strange, because we should have like 2 different things fighting here. By chance it might be a long delay. AB F7. Oh, okay, we got that one. F7 75. CDAB 94. That one again. AB F6. That one again. I never see 96. Did I do something wrong here? I think I made a mistake and 96 doesn't exist because I didn't see that one at all. And then I have 5 5 different MCUs, which would be correct in that case. C5, that's our host. And then we have CDAB82. Then we have CDABF6 again. Long time nothing. CDABF7. I think that works. We have all 5 MCUs. What? C5, 5A. Oh no, that's a collision. And it wasn't detected. 5A. There is no 5A. That must be a collision. It doesn't look like it was detected because 5A, there is no 5A here. Shoot. CDAB94, 5A. I'm wondering if the checksum, if that one would be discarded because of the checksum. 41. C4. No, 41 was the host. Where's our collision? F7. What? Am I? Here. 9-4. Where's the packet that I thought I saw? Am I wrong? There is no 5A. They do something wrong here. Okay, F7. Okay, I might have misjudged what I saw here. F7 again. Where are the others? ABF6. It's strange. Some of them come more often. 8-2. But it's so cool. It seems to work. 9-4. Okay, here are my stats. Huh? Here. 82. 3 times, 4 times 94, 3 times F6, 5 times F7 and several times C2. Yoo-hoo! It works! Let's do more blades. More! We have 4 MCUs. What? We can put 2 more blades there. Let's program them. Let's program them. Hope I can make it work. And then we will update the resistors, and that's about it. I need to make a programming board for that one here. Yeah. Uh-oh. Did I connect it wrong? Might have. Doesn't no worky. Eh? Oh yeah. Yeah. Yeah, no worries. I will give you an update in a second. Let me just program 2 blades and then I will give you the recap that will be also done on, here we go. I'm updating, oops, no, wrong, here. Hex, hello, I didn't see you coming. Just hearing the TTS, okay. So this blade should be also ready. And now but that hot glue connector helps. Sometimes it struggles a bit. Bloop. Bloop. Uh-oh, this one. Okay, no, that worked. Okay. Peeps. With debugging, there are not many more. Oh, we can move that one over and do another one. You know what? Oh no, I disconnected it. Okay, now let's do. That should be enough for now. We have 1, 2, 3, 4, 5, 6, 7, 8 MCUs. 8 MCUs. And eight MCUs. This is how it looks like. It's 8 on the blades and 1 host. So we have 9 in total that will be colliding or not colliding. Here we go. Nice. Okay, let's stop it and then scroll through and get all the IDs. Sweet. Okay, CD94, we know that one already. That's Mr. 94. Then we have C5, that's a host, 5A, yeah. Then we have CDAB41, that's a new one. Welcome to the club. That's 41 OC59BC, and then that should be another one 67. I think there is a checksum in that one as well. 74. Okay, nice. This is a new one that we don't know before. Then we have CDAB5B, that's also a new one. 5B, and there is 81. 81. We have AB. Put this closer to. F6. F6 is known already. That's the CDAB F6 and then 1C. Yes. Nice. Okay, that one is also known. Then we have CDAB 9D. 9D is new. 9D. What does it see? C3. That's a new one. Then we have AB A9, also new one. CDAB, yeah. C5, CF. Okay, now we have already 4, 5, 6, 7, 8, 9 MCUs. I think we got all of them now. Yeah. I hope we don't get a new one. F6 is known. 9.4 is known. 5B is known. Ha! That works! What? No way. 5B. Oh, that one again. That was close. The other ones are waiting for too long. 9D. Nice, that works. Okay, we got it. We actually got it. That's why we also get a nice break here, because everyone sent their packets here. Oh wow, 9 different MCUs and all broadcasting on the same lines and handling the collisions gracefully. This is awesome. Maybe I should take so 9 MCUs all on one bus, handling the collisions and delays, and everyone gets to send their handshake packet. Nice. Okay, now let me give you a recap of this project in MS Paint. Here, MS Paint. So, all started with 10 cent Risc-V here. Those here, 10 cent Risc-Vs. I put on this board here. This is the carrier board. 16 of them with one LED, and this is a carrier board, and they share a 8-bit bus, which has a clock signal and a command signal that we don't use anymore. I don't know if I even knew it. And then the recap isn't done. So, and then you know, that was like last year. I published like a year ago. I published a video on this Risc-V supercluster with 16 cores, but the bus was barely working. And now we also made, like 1 year ago, we already made the Megacluster, which has 16 of these here, which have 16 each, so 256 cheap MCUs and LEDs and many GPIOs. And I decided to split the whole board, since it's really a lot of connections, to blades, and we can plug the blades to the base, and the base has basically the base, and those MCUs have the same bus like the individual MCU with those 16. So we have like a 2-stage bus, like each of 16, and one of those hosts share one bus, and all of the hosts and this host share also one bus. So we have 17 buses at the end. And what we tested now is a protocol that works without the command signal. So usually we would say, okay, we pull command low, that's an open drain bus, and then the bus is basically busy. but I forgot to route that command line on this bus between those 17 MCUs. So we needed to implement something different, which basically uses this clock signal to see, okay, clock is idle for some time, for a few internal clocks of each MCU. So it knows, oh, I can talk now, and then pulls the clock low and starts to sending data. And then there is this collision detection. So on each, like, it sets a byte on falling edge. It sets the data byte on all 8 bytes bus, and then on rising edge, it checks the state of the bus. If there is someone else talking on the bus at the same time, the data won't match, and then it basically breaks and starts at a random delay the packet again. So this way collisions are handled gracefully somehow. And we have also so the receivers, since only the senders know, okay, this is my data and it's basically broken, and if we have like collision where the packet is basically modified or the data is wrong, we have added at the end this checksum, which is basically the last byte with XORed bytes. So any receiver that doesn't send and receives that packet is able to check, is this packet valid? If it's not valid, it will basically scrap it. And that's how this bus is working. Now we need to check if we can receive data at some point. But I think for this stream, we got enough of that. What we can try to do is to increase the clock speed. We don't see that because they don't share a clock. Sometimes it happens, but it's so rare at this point. At the beginning, it will be happening very often. So we can maybe do a one shot or something. We can try a one shot and see if we get like canceling packets. So how do we do? Run stop. Maybe I can make it. Yeah. So that's what we'll try to do. I will try to stop it instantly so we can. Okay, I stopped it instantly, and then we go to the start of this. Probably I was too late already for collisions to happen. The random seed is set by each of these MCUs has an 8-byte unique ID, and the seed is basically taken from the unique ID, which is also a brilliant move. Here we go. Do we see any collision packets? No, we were too late. I don't know how to do a one shot here. Yeah, I don't see collisions happening here. We were too late. Maybe we can. Oh yeah, we can. Wait, we can. I don't know how deep our memory is. Maybe under acquisition, memory depth is 14 million. Okay. Let's try to capture. How do we? There must be a way to do like a trigger single here. Okay. Wait, that was wrong. No, wait. Single doesn't work. Can I do a single setup? pulse, type pulse. Can I do like it? No, that's nope. Okay, let's do. Let's see if we can do. And it was too fast. Too fast. Okay. Maybe we can, but I don't think we have the memory is deep enough to. Oh yeah, I could use that. Oh wait, we might have. Yes, there is a collision. You can see a collision. Oh, I need to record this. Okay, here is the case of a collision. That's amazing. Look at that. We were able to capture it. Here. That's even like probably several MCUs that are trying at the same time. Look at that. This is cool. So let's check. CDAB 41 OC, and then something happened here. So maybe one turned on or something, and then it corrupted this one. But this is until this year. That's a valid ID. But something corrupted the bus, and it was detected. Here, there is another collision. Oh, cool. We were able to capture, so the memory depth was high enough here. Okay, so we have CDAB 9D. And the 9D is a valid one, but then what is this one here? This was probably this byte. Something's going on here. 9D OC is correct. And here we have a corruption here. Something is going on. Jitter. Maybe another one is coming online. Here. There is also a cancelled. Yeah, but doesn't need to be necessarily a cancelled packet regarding, like, related to a collision, just by the bus being jittery. Yeah, but we can see that it basically works. It cancels the transmission, which is all we know. All that we wanted is to can. Okay, maybe I should record this. Yeah. All we wanted is to basically see that packets that collide or have a broken bus for whatever reason are cancelled, and this is what we can see here. Not all bytes are transmitted. So it's 16, 17 bytes that are transmitted each time, except for the collision cases here. Nice. Collision. CERN. I mean, they have to aim really great. Okay, peeps. So I think this is great. Okay, now. What we can do is we can improve the slope. On the first collision, the delay on the end of the data was slow or fast. Yeah, you know what's happened there? You have two MCUs pulling down. Oh, I could do something to prevent this happening on startup. I can tell you what we can change in the code to prevent at least the collisions on the startup when the MCUs are powered on, because I can see a source of failure here. But if you have like two MCUs pulling down and they both release slightly different times, that it wouldn't appear like instantly like a jitter. It will appear like a slower slope or something, or a slope and then faster, or whatever happens there. No, it will, yeah, it is a different speed of rising edge. So we can do a better pull-up, but now what I want to do, okay, we didn't use that. What we can fix is when we initialize the MCU and we initialize the GPIOs here, yeah, that's basically what's happening. It stops talking on interruption. So what we didn't do here is when we start, okay, no, the data is all right. Here, we need to set the clock before we change the pin to the mode, to the open drain mode, because then we make sure that it's not pulled down on initialization and then released. So this needs to be changed. I hope that works. And we need to change it here as well, because that's one issue that we can improvise. Change. Yeah. Oh, you mean I'm messing with the data here. And they're pulling down as well. Oh, what? No, this is wrong. We need to set the data. We do set data also high before we change the pins, because we mess with the data of a different sender. Set data and then XFF. That's needed here. Same here. Data FF, because before that one, every packet will be corrupted until that one sends the first successful packet, or what? Yeah. Okay, so that might be fixed. But it was a good collision test. And now we can swap the resistors. That will be cool. We do 1K. What do you say? We have 5.1K right now, and we can make it 5 times faster. Like, look at the slope. I don't want to make it like draining too much. And so 1K will be alright. This is 5.1. It will be way steeper. Okay, let's do it. Yeah. Plop. So we will have soldering action, and this will be basically it for today. After we tested it once more. Oh shit. Oh no, everything is okay, I can disconnect it here. It's like messy. Whoop. Look at that mess. My Monstera. No, it's not giving up. We are successful. 120 ohm. How many of those are at each blade? Like, we have two for each blade, like 2 of those, and then there will be 32 in total of the small. Really? Terran, why on each side of the bus? Why on each side? As termination? You have the same scope. Boop, boop, boop. This one here. That's the parallel probe. There should be a 120 ohm termination resistor located at each end of the bus to prevent signal reflections. Yeah. But wait, okay, now we need clarification because I'm a total noob. I never had like signal theory on hardware level, or at least I didn't pay attention. So let me do it here. Yeah, CAN bus is longer, so okay. So how does it look like? We have many MCUs, all connected to one line. Boop. And then we have beep 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 beep. So there is this end, there is like, I don't know, it's some end. It could be in the middle here. And do you mean like in front of each MCU there needs to be a resistor? Or what do you mean? Nope. Okay. On the left. Okay, but what we have is more like something like that. So that like that, like that, 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 that. More like that. What we have looks like that. So it's even like different length, different whatever. So where do you put it? Do you put it here and here and here? Yeah. Yeah, so it would have like a different, because this end is on the blade. $33 ohm in the yeah. So basically we would do resistors in series, so the signal will basically calm down at some point, the reflecting one. But the issue is now, if we have like only few blades, then the rise time is a different one. Like if we have no blades at all, rise time is the lowest. Oh, okay. The ATU would put it then here. Okay. Yeah, probably. Yeah, you know what? For my experimentation, it looks like it works without any termination, and people are not complaining. But okay, let's calculate the current. So if we do what did you 120 ohms, 120, like 100 ohms is 10 milliamps already. No, it's at 3.3 volts. At 3.3 volts it's already 30 milliamps times 9 times 10. That's 300 milliamps alone for the bus. This is glowing. I don't think I need it that fast that it would just justify for 100 ohms. We're not in. So Terran, how do you calculate, or if we clock, let's say at 1 megahertz, how much of a resistance do we need there for this open drain bus? A total resistance. 1K will do. Say again, 1 megahertz bus. Okay, bus capacitance is high. What is used on the C64? Let's just. It has also an open drain or open collector bus, so it has to use some sort of value there. Should we measure the capacitance? It gets bigger if I potential long bus, but we calculated 120 ohm is not an option for those many lines, because then we have like 300 milliamps or 500 milliamps of dissipation on those resistors. They're not. You would play with resistors? Let's yeah, okay, you know what, let's take a look at this. This was our recording. This was our recording, and we have 2 microseconds slope here with that many blades. There will be slightly higher slope. Is this like, yeah, it says 2 microseconds. What is this? No, where's the, wait, yeah. So let's see the slope, like 2 carats, maybe 3. Let's say 3. So it's about 5 microseconds. So if we do 1 kilo ohm, we'll reduce it to too many bias resistors. What bias resist? We have like, oh, versus the drivers, you mean like, oh. Yeah, I know that will change, but not that much. It's only 17 in total. This is already halfway there. We have 9 and the max is 17. It's always 17 is max, because we have split the bus, thankfully. Output impedance of drivers. Okay, you know what? Let's replace it. If we use 500, I check what I have. We can use 300. Then we have like dissipation of, yeah, let's just use, I have a buffer. No worries, we will do a 300 ohms here, or 200, that will cut it to 250. Oh, that's 300 ohms, should be fast enough for everyone. Where is it though? Where are my 300 ohms? That's not resistors. 1K? I found the 1K already. That's 5.1. $5K. Where did I put? I used them recently. Yeah, 300 ohms is not that high. Where is my... Oh yeah, we have 300 ohms here. Look at that. I have even a box that says 300 ohms. Nice. ohms, 300 ohms, 300 ohms. Whoop, whoop. I hope I don't destroy it. 3 volts. 3 volts. At least at that bus. We could have 5 volts on the one with... yeah, but no. We can't. It's always... The small MCUs are tolerant, 5 volt tolerant, but not the bigger ones. A what? A decent what? Sorry, I didn't get it. Ugh. Oh shit! I melted my power cable and I touched it. Oh fool. Oh, yeah. Okay. I think it was. Now I need to check if all of them are the pull-ups on my schematics here. Yeah, 10 milliamperes per line, but we have 9 lines in total. And we will have, like on the other bus, which is 3 times slower, we will have also like 16 times that. So we have 17 buses in total, 9 lines each. Yeah. So we have, you can calculate like 17 times 9 lines, 9 times E or A or whatever. That's a lot of current that need to be considered. Really. We will take a bigger resistor. I think 1K is enough for the slower bus, because that one, like the bigger MCUs, can run at 144 megahertz, but the smaller ones at 48. But we are not using every clock cycle, so. Oh wow, yeah. And that would be a lot. I don't want that. I can use 300 ohms on the main bus, and on the other buses I can use 1K. That would be fast enough. What did I want to do? Oh yeah, I wanted to check this one here. Bus clock. 3.3. That's not really relevant. Let me get them off first. Thankfully I made them really in one row and accessible here. Oh, low temp paste, nice. That's why I initially took this resistors, but 5.1 is unfortunately a little bit too slow here. Oh no. Yeah, I can't do that. Shit. I need the soldering iron. That's huge life. Now I'm using an LDO. But that one powers everything, which is already terrible. Don't worry too much. It's not that bad. I don't have too many power layers on the PCB such that it would matter. It's 4 layers and ground rod. That's insane. Oh yeah, that can happen. Uh-oh. We had one upside down last time. I will also make it upside down this time. One of the resistors. Oh fool. Where's paste when I need it? There we go. Side mounted as well. Okay, you will get both. Looks like traces are, I don't know, let's check. Side mounted comes for you. Who's the person that requested side mounted? I can only hear the voice. Tombstone, yeah. I'm also a side sleeper. Shit. Now it's flat. I will make it diagonal. No, didn't work. Shit. Oh, that worked. Nice. Oh, the power lines are thick. Don't worry about that, I took care of that. Oh no! The side mounted won't lay flat, I'm sorry. I really don't want to desolder it again. I can't see really. Lost the resistor, it's too hot. The soldering iron is way too hot for that. Oh no! Everything is... I can start over again. I should have soldered all at... Oh no! That's a resistor fondue. I don't know if you can see. You can see probably. It's a huge mess. I have to start over again. Yeah. But the data lines are not carrying that much current. Each data line has only 10 milliamps, which is fine. It's not. I have here a spatula with some low temp solder paste that's dried up, so I'm using that to solder the. I didn't want to switch the type of solder used here right now. Yeah. I can't see what's happening there. It's a huge mess, but it will be a nice trigger to people on YouTube to shout at me. Why are you shouting at me? You know the meme that I just referred to? Ah, a quote. Oh, the pretentious quotes are really terrible. Really not. I really don't want to solder 256 dip package MCUs. Oh, yeah. Oh, they are randomized, so really I didn't. We made them bad. It was better at some point. It's just some hard-coded stuff, and then it got really bad. I hope each of them has the connection. Okay, good enough. If it works, it works. If it doesn't, it doesn't. Ship it. Why is this still running? I'm not even using it. Yeah, we can't put this in ultrasonic cleaner because it's too big. Oh no, did I just move the paste around here? Shit. I just painted my complete board with paste. This is not good. Paste remains. Ah, it will work. Oh wait, I found a side-mounted resistor. It was there already. That's cool. I will show it in a second. Just clean it up here. Okay. Peeps. This is the solder job from now. And here, don't know if you can see it. Shit, it won't focus. Here, this resistor. Yeah, I can do that. I can always do that. Old toothbrush is always amazing. Nice. Yeah. IPA. Toothbrush. Everything clean. Let's plug it in and see what happens. I will open the window because the IPA fumes will. They're amazing if they are worn down. Oops. Huh? Oh. If they are worn down, then they can even clean sideways. Nah, all good. Here we go. Whoop. Alrighty. This is, I hope this is a clock. Ground is on the USB port. Okay, if I don't use proper shielding, that's amazing, because in that case it's easier to get the ground with this huge clamp. Okay. Yeah, it's not plugged in. Let's see how sharp of signals, how sharp signals we have. Ui, now we are talking, peeps. Now we are talking. Look at that, my dudes. This is amazing. Now, with the new resistors, 300 ohms, this looks like a square wave. Let's see. We didn't change the clock speed, but let's check the slope. That looks like 20 nanoseconds, 200 nanoseconds. That's, yeah. We can plug in even one more and see how the slope changes. So we have now something like that, and we can plug in one more here. There's like 2 more MCUs. Boom. Much more better, huh? Yeah, that looks like 100 nanoseconds. Stable. Wait, okay, that's falling. Let's measure. So, how do we measure? The threshold or a safe? Yeah, I would say that would be like 100 nanoseconds would be safe. Look at that. We have a voltage. If we just go to this edge, yeah, we are at complex ringing. You mean that one here? Or high to low? Oh wait, the other one. Oh yeah. So is that because it's very fast pulled down? Oh, you know what we can do? We can change that slope as well with let me check something. Oh, am I recording? Yeah. We can fix that. I will remove all the blades. Yeah, but we can fix that. I show you the way we can fix that. Here we go. Let's run. This still there, still there. Now, let me do one thing. My magic, let me do my magic here. Let me do my magic. Wait for it. Here. Didn't change. Let me change again. Yeah, you know what should... that didn't change. Okay. Okay, what I did is I tried different. We can do basically change the slope, but it seems to be only the slope for high. Yeah, we can check that. But it's not that bad. Oh wait, that's worse. With 5, we can actually yeah, 200. It says here minus 276. Yeah, that would be a solution. Okay, now we have 270, still 270. Okay. Yeah, it isn't a problem. They are really robust and very... Dudes, this is amazing. I'm not even sure how much of... if we can go that fast. Dudes and dudettes, yeah. We can try a faster clock speed now. Should we try a faster clock speed and then see when it starts falling apart? So let's try. So there is like just one thing. We have basically here. This is 256. That's 300 ohms. Autobahn speeds. Yeah, you know what? Now we are doing the following. We are running it like one phase, so low and high. We have 256 clock cycles, which is not clock cycles. It's I think it's half clock comparator here. So the counter will be every 500 clocks, and in that during that time it needs to run to process the complete bus, which is implemented like that. So we might, the process is a switch, it might fit, but at some point it will fall apart. So the clock will not be like equidistant, and we need to check how stable that is. So I will change that now. to 50, and then let's see, let's double the clock speed, and we will see if, okay, it still manages it. We don't see any jitter, but there is also not much going on the bus. Let me check it. Oh! It already falls apart. Look at that. It should be equal in size. It's already falling apart. It can't do this frequency. Yeah, the data is always set on falling edge and is read back on rising edge. But do we have measurements? Let me check. Let me check if we can do 80. We can maybe improve it with code. Yeah, 80 works. So we improved it by what is it? 12%. We can try 60. Works. Let's see. It's almost there. Yeah, this is where it falls apart. 50, 60 still works. It's strange. Here, 60. 60 is working better. So the issue is, if the interrupt takes too long, it probably like skips a turn or something. Yeah. So let's we either need to improve our, but on the other hand, if you make the clock so high, you spend all your time in the interrupt. You don't want to do that. This is like really, really oh, I mean, okay, let's measure the frequency here. Where is it? Measure. So time. Yeah, we just swapped. No worries. We just swapped the resistors from 5.1 to 300. Yeah. We might want to assemble it at the end. Where is it? Where is... Hey Bob, welcome. Okay. Do we see it? Yes, frequency 740 kilohertz. So it's almost 1 megahertz. And the small ones are clocked even slower than that. So the small ones will be only 200 kilohertz or what? No way, I need to improve the bus. This is now like the very... This is now a very cleanly implemented. $300 is okay. I use that for my VGA boards as well. So it's idle. It's either idle or sending. During sending, so receive, send,
we do set clock. Can we improve? You know what? We set it. You know what we do? We set to. Oh, this is the wrong one. We set it to 50. Then compile it, run it. And then we will try to optimize the code until it works. So something like inline didn't change anything. Just inlining them, but it will probably not happen. Set clock. Hey, the sheepu, you missed everything. We had collisions. We had 9 CPUs at the same bus sending handshakes. We switched the pull-ups resistors to 300 ohms, and now we're trying to optimize it a little bit with like the low-hanging fruits, but it's the low-hanging fruits are not that low-hanging in that case, because like the sending method, set clock, set data. Oh wait, clock. All of the devices, but all of the devices can cancel already if we like do an early target detection. Air transmission. If like the second 8 bytes are the target, and if the target isn't 0, then all the other receivers can cancel listening already, because it's not targeted to them. So data bus broken. So let's check what we got here. We have in this whole process, we get the clock, we go to send, and basically everything on high edge set clock 1 is faster. So get data, and then set data. So basically previous clock out. The problem with this case is here we have basically reading back the register and setting the register. Huh? Oh, Dave Darko. That's for a byte. There's always a byte sent on the bus. Hello. Hey, you missed all the fun already. We are trying to optimize. We can do. Okay. All right. Okay, that's good. Previous clock count. If previous clock count was 1, then we have the clock is currently clocking at 600 kilohertz. 600 kilohertz. Okay, so previous clock. Wait. This is not ASIC. Sets CRK call. What? Yeah, it's a call probably. Because it's a template. I don't know. It depends what the compiler does with it. It's a template. I made it. I defined it inline. So probably. You know what? You know what we do? You know what? Let's do that. Wait. Bam. Says set tick as SR. This is where we get bam. Return other interrupt time plus plus. It never ends up in bus. What's going on? Here, set data. Okay, you know what? Currently, we are doing like a graceful stuff here, but we could also doing it without the readback. GPIOB, let me check what else. So if we do this without that, yeah, we could pre-process that data, but oh yeah, stop. And doesn't work. It's broken. Nope. I break it. I use B for something else. Oh yeah. No, clock. So what we can do is setting clock and data in one go, because that's on the same line here. B. Both are B. Shit. Set data clock. We could combine this. In that case, what we can also do is use the set and clear registers. Basically, clear clear that's two writes. Oh. Let's see if that works. Oh, that worked. What? But now it's not written in the same clock cycle, so we have like two separate writes. But that worked. Look at that. Now we have 880 kilohertz. Done! Round it up to 1 megahertz and we are good. It was just this thing made it break. Crazy. We could go lower. Let's go lower. Let's try 40. Let's go faster, Rara. Boink. Broken. That doesn't work anymore. That needs two clock cycle. Yes. That's what we try, Foo. But it doesn't work at 1 megahertz. We can try make it work. We can try make it work. So if we debug, you know what? What we should see is when we debug it, it will always land in the thing. Statistically, it will land when we pause it. At that point, yeah, here, setting the clock. So this is this assembly. $26. Jump sysdig handler. What? It's a jump. Is there no return or something? It's you. No, you know, what we can do is like resets. So what happens here? It looks like, you know what it does? It unrolls the whole code. There is no comparison here. Clear. Oh no, it is. It's comparing here. I mean, I could do a set and... which is stupid. It's stupid that it does that. What we can try is, let's do basically the same as we did set clock as we did with set data. Might be faster just because we can do everything in CPU. That's basically... oh, C shit. Okay, that's basically C C and shifted by 2. And C shifted by Z and not clear. That should work. Okay, let's try it. That should be faster without any branches. Not good enough. If that was inline, it would work, but it isn't inline. So basically what we can do is make this clock thingy here, set clock, an inline thing right now. Let me check. Yeah, it's still the same. We can check how far we got down. So let's try 48, which is halfway there. We will do binary search. No, 48 doesn't work. 4A. Yeah. We are down to 4A, 49, no, 449. Ah! That's funny! Now you can see if it's like at the random state, if the cache, we have cache misses or not or whatever. It's quite random, but now... Okay, so we can, you know what? We can run it at this clock speed and then basically see here, we run it at this, and then we can see whatever improved it or not. Yeah, but this is the bigger brother. That's the 203. The other ones, but they work basically the same. Okay, so let's check if we can make it more refined. Bam, where are we? What is this? Some sort subroutine. Time plus plus. Add E. What? We don't even need time plus plus now. We are not using time. We could use even the register if we wanted to. I mean, that's really cheap to remove that one here. But it seems it's struggling to... Let's see if that fixes it. Nah. A little better. Yeah, I don't like that. Let me check if we can find a different way of handling it. So, currently the low phase. So last one is send. Last one is basically previous clock is 0. That takes time. The get data. So for checking, for collision, basically takes time. Index.
high clock count. Zero. It's an integer. Integer. I don't see. The problem is. Oh, what? Yeah, V. The problem here is. I mean, we could optimize that here to be only one transfer, but we got the problem already that we said we get the clock that's on the receiving side. And collision testing here. So we could already save it. Only doing the get the clock if it actually But that needs a major redesign. I mean, I can optimize it. Function first. What we can do is we can move clock away. So if we do, basically, we don't have clock here. We move it here. Where else? Receiving side. Clock. Oh. That won't work. We can't. Yes, I could, but I didn't need to redesign it. Also, what I can have the set clock. Oh, previous clock. No, we can do something else here. Send. Huh? Oh yeah, that's the case. And previous clock can be basically implied from this here. Else, if some messing with the clock. That's like collision detection here. But this is too much already. I think this is too much. We should always be sure that the clock works. I don't want to mess around here. You know what? I revert this. Thanks. Yeah. So I will put it back here. That's not the thing. We have clock and data at the same. On this bus, we could actually save on the reads and writes, but the problem is we have supercluster bait. This one has clock and data on different ports, so that won't work already. And these are on the same. These are on the same. On the same line. So in that case, we don't save anything. So this is basically. So when we are sending, we have read the clock, we set the clock, we have read the data, we set the data. That's 4 I/O writes and reads, and the bus is slower.
It's 4 bus writes or reads in total. That's why it breaks, and that is slow. We can check the data sheet. Let me check the data sheet, and then we will. Now we are already almost done, because that's the chat. No, don't look at my chat. No, that's you. Where's the CH 32B? Not datasheet. Yeah, datasheet has it as well. I think it does. Okay. Int between the set clock and the set data. Oh, there is no, we are already in the interrupt. The other interrupts are halted. So I don't think that will happen. And basically what happens is we set the data at falling edge, but the receivers read it at the rising edge. What we could do is we could basically set the clock weight. I think I did it this way. Yeah, we set the data and then we set the clock. So oh wait, no, this is the wrong here. Oh, so you have some racist politics. Okay, I'm tired. Let's check at the reference manual. Hope we can. Oh no. Again, I downloaded already a million times. So slow. Because I think the bus is really the slow part here. What we can do is we can do something different. Okay, let's take a look at this here. Plop, 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 plop. So, oh, that's fast. HP to PP2 bridge, and then we have this, and then we have a MOX and system bus. I don't know if there's like a delay of a few clocks, but I set the clock speed too high, I think. Let me check. Clock command GPIOD. I'll check. Prescaler. Peripheral clock enable. Okay. PB prescaler. By configuring blah 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 RC configure register, the clocks of HBPB PB2 buses can be configured respectively. These bus clocks determine the access clock reference peripheral interfaces mounted below. Blah blah blah. So prescaler, let's check if we can find prescaler. No. Okay. HPB pre2. Oh, good night, Max. Okay. Pre div 1. HBP prescaler, what? Oops, not changing that one. Bye. I'm wondering if we can do something about that. Peripheral clock commands. Reset. Config. All right, I mean, we managed everything today. Thank you for your helps, peeps. Good night, everyone who goes to bed. I will quit in 5 minutes or 8 minutes as well. I will try just one thing, checking if we can do something about the clock speed of the peripheral bus, which is basically here. And we will do clock config register, and we will just check if it's pre-default. Clock is not divided, it's default. So I believe we can't do anything here. Thank you for being there. 11. 0, 11, yeah, that's basically peripheral blah 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 RCC config and equal 1. You can rewatch always. There is no, wait, tilde. Okay, so this is basically bloody heck. Bloody heck, that would 12, where's 11? 11, 13. So that 0 clock is not divided. But that will not change anything. Look at that. Yeah. So was worth trying. Okay. There is no way of making that faster except for us to refactor the code somehow. So we won't do everything at the same phase here. Or
You know what? We just missed the clock a little bit, which is we can do cystic control reset. Let me check. Tick tick. Stick resistor. Control resistor. A tick. There is a reset. Counts down to 0 when counts to 0. Tick enable exception. Systic enable. We can always there is like this systic control. We can set the count to 0. Count 0 and there is no reset. If we don't do a reset here, but I need to find that control here. Cystic control, what is this? Cystic. After up counting, the compare values start counting from 0 again. And after down count, I am using it already for our bus. Start counting again from the compare value. Continue up count after up count to the compare value and down count from the down count, up count. I think this was the reset. Auto reload. That's 1. That's bit 3. Bit 3, 0, 1, 3. 0. Okay. So we just reset it, but it won't work. Now it's not that great. Oh. Yeah, you're right. That was probably the divider. Damn. Where's my tick? I need to move it again. That was the clock divider or something. Yeah, nothing happening here. So probably nah, no good. I should not use magic numbers here. Alrighty, peeps. the highest speed we can go is unfortunately 4A. And this is 900. This is 950 kilohertz. That's all right. We can round up by 5%. So close. Yeah, I can do this if I do assembly, but then the code gets ugly. I don't want to do this anymore. 0 o'clock here. 2nd of May. Thank you very much, peoples. I see you some days. I don't know. I need to edit. Oh, you can already see the well-controlled bus design. You are an ass for saying that. My bus is perfect. Look at that. We are reading at rising edge. Uh-oh. What is there a delay? What is happening here? Uh-oh. That looks like oh, who do I rate? Who is online? I need to investigate that issue. But yeah. Not well designed. Yeah, no, it's all right. So, who do we rate? Who do we rate, peeps? Hoffman is online. Okay. Let's do Hoffman then. But anyone else? Ashens? Ah, yeah, I should be paid 250k as well. Here. Okay, peeps. Here we go. Thank you very much for joining. Rate is set up. And you enjoy Hoffman. And I see you next time. Bye bye.